All right, ladies and gentlemen. So for this presentation, we're going to talk about the respiratory system. So the respiratory system is very simple compared to some of the other systems that we'll talk about. Basically, it's just all about getting oxygen, gas into your body because you need this for what's known as cellular respiration. When you combine oxygen gas with glucose, which you take in from your digestive system, and go through this process of cellular respiration with the required enzymes and stuff, that's how you generate energy in the form of the ATP molecule. So that's why you need the oxygen. And what you're trying to do is get rid of something called CO2 or carbon dioxide. All right? And that's because this is a waste product. And it's a waste product from respiration. Now, if you don't get rid of the CO2, your blood acid levels go up. The pH of your blood actually increases. And if you recall from the very beginning of the year, one of the things we talked about is that all organisms must maintain homeostasis. And maintaining homeostasis is keeping a consistent blood pH level. And so that's why you have to get rid of this carbon dioxide that's a waste product of cellular respiration. Now, your circulatory system helps you transport this throughout your body. That's what your heart, your arteries, your veins, your arterioles are all for. But your respiratory system is what allows you to take in the oxygen gas and remove the carbon dioxide waste. So the respiratory system is very simple. You have your nasal cavity. It's actually always preferable to breathe in through your nasal cavity, although I'm sure you're all aware you can breathe in through your mouth, and that's because your nasal cavity and your mouth both meet in the same place, and that is the back of your throat in an area. You take in air, it goes here. You take in air through your mouth and it goes there, and the area they meet is the pharynx. Now, it's actually kind of an evolutionary mistake that the pharynx is where you both breathe and eat, like it all meets in the same place, and that's not a good thing. All right, you actually don't want that to happen because that's why you choke. That's the number one reason that you should never eat and speak at the same time. It's because speaking requires breathing, and you don't want to do that because if food ends up in these lung passages right here, that's when you choke because your air pathway is broken, is blocked up. And so that's why you have this structure right here called the epiglottis. It's actually like a little cover for your air passageway, so you don't actually choke. And that's why you never want to eat and speak at the same time. But once that air that's filled with oxygen gas gets past the epiglottis and the pharynx, it ends up in this structure here, which is known as the trachea. The trachea is just a tube that runs through your chest. It actually runs side by side with your esophagus. The trachea carries the oxygen into what's known as the bronchi, which are these two big tubes. And the bronchi splits. One goes to the left lung, one goes to the right lung. And you'll notice here, your left lung has 2 lobes, your right lung has 3. And that's because your left lung is actually slightly smaller, and that's because your heart sits on that side of your body. It's actually not as big, although you do use all of the surface in both of them. Now, once that air travels through the bronchi, it ends up in all of these smaller tubes. And if we go over here to this diagram, you can see that those smaller tubes are called bronchioles. So we're basically just getting small, like trachea, bronchi, bronchiole, all right? And what the bronchiole ends in is these little structures. You can see they almost look like little tiny balls, or sacs is the word we use, and they are known as alveoli. And it's the point in the alveoli where you actually take in the oxygen gas and give off the carbon dioxide. But none of that would be possible without this and this, which are your pulmonary, all right, because if you recall, the word pulmonary means lung, okay? They are your pulmonary arterioles and capillaries. Basically, the heart pumps blood into your lungs, and the blood that your heart pumps into your lungs doesn't have oxygen in it. And so it gets pushed all around these alveoli. And since there's oxygen in the alveoli and not in the blood, the oxygen dissolves into the blood. And then since there's carbon dioxide in the blood and not in the alveoli, carbon dioxide dissolves out of the blood into the alveoli. And then the blood gets pushed away. And so you have a constant stream of blood that does not have oxygen and does have carbon dioxide. So the exchange is always occurring one way. And that exchange happens at the alveoli. That's actually the real location of gas exchange inside your body. And you can see, if you look at this diagram over here, the alveoli are just covered in those capillaries. Capillaries are the thinnest blood vessel. That's where the exchange of nutrients, waste, gases, all of that stuff happens. And it happens in these lungs. And these lungs over here are just filled with alveoli. And so gas exchange is happening in thousands of places all at once. And honestly, that's the basics. The only other thing that we really want to bring up is you can see this line that I've drawn here underneath your lungs. That's actually a big, strong, smooth muscle called your diaphragm. Go ahead and breathe. If you sing or you speak in public or you act, you know that when you speak, you always want your abdomen to push out because your diaphragm is filling your lungs. And the only thing that's really interesting about your diaphragm is that the muscle contraction actually opens your lungs, and that creates this empty space and air gets sucked in. So it's actually a contraction of your muscles to open your lungs. And it is a rest to close them, which means that breathing out is actually a rest, which most people seem to think it's the opposite. But what happens is your diaphragm pushes your lungs out, which creates all this empty space. We call it negative pressure. And it pulls the air in to your lungs. And then when you relax the diaphragm, the weight of your chest and your rib cage actually just collapses on top of your lungs. And that pushes the air that's inside of them out. And that's actually how the breathing happens. So what I want to discuss now is a little bit about that gas exchange. So here you have an alveolus. So this right here is one of these sacs. And you see how it's like right up against the blood vessel. Now, what you'll notice is up here, I have blood that has really high carbon dioxide because that's coming from the body after the body's already taken what it needs out of it. That's filled with waste product, okay? And so what happens is, since there's a lot of CO2 in here, and there's not a lot of CO2 in here, the CO2 moves in to the alveoli. And then what happens is, there's a high amount of oxygen in here, and a low amount of oxygen in the blood. And so the oxygen moves out. And then, as the oxygen concentration gets high, the blood runs away. And then new blood comes in. And the new blood has a lot of CO2. And so the CO2 dissolves into the alveoli, and the oxygen dissolves in. And this continues until you exhale and get rid of all the CO2. And then you inhale, and there's more carbon dioxide, and this process just continues over and over again. Now, the one thing that we want to talk about is that your diaphragm contractions are involuntary, for the most part. I think all of us realize that you can control your breathing, but if you ever hold your breath for too long, your body will knock you unconscious and force you to breathe. And it does that because it realizes that breathing is a necessity for life, and so it is an involuntary process, even if it does allow you to take limited control from time to time. So I know that seems like it's very rapid and almost disjointed, but I just want you to think about the respiratory system as almost a tool of the circulatory system. You have a respiratory system because oxygen is so important and getting rid of carbon dioxide is so important. But honestly, it works in direct conjunction with the circulatory system, and it's almost impossible to discuss the two of them individually. All right, that's it. That's the respiratory system.